Okay, solving first order ordinary differential equations. Well, first of all, I know this is a first order ordinary differential equation because it's got just the first order differential in it. So that's dq by dt, and it's got an equal sign in it, so I know it's an equation. So this is a first order ordinary differential equation. What I've got to do is to solve this. So the first thing I do is take the qc over the other side. So r dq dt equals minus q over c. Then dividing both sides by r, I get that dq by dt equals minus q over rc, which I can think of as q times minus 1 over rc, effectively, separating those out. Because now what I want to do is bring the q over to the left-hand side of the dq and bring the t up to the right-hand side. In other words, separate the variables. So therefore, 1 over q dq, dq equals minus 1 over rc dt, separating out the variables. Now I integrate both sides to solve the differential equations. Integral of 1 over q is log q, and this equals minus 1 over rc times t plus c. And that's the general solution of the differential equation. And in the exam, that might well be the first part of the question. So that's the general solution. It's in implicit form because I could do with just having q equals to something, and also I would like to find a particular solution given some initial conditions. So given that when t equals 0, q equals q naught, I can find, first of all, the value of c. So what I would do is I'd say, okay, when t equals 0, q becomes q naught. So the log of q naught equals, if t is 0, that first term has disappeared, c. So directly I've got that c equals log q naught. So now I can write the particular solution to the differential equation. Log q equals minus 1 over rc, or minus t over rc, combining them together, plus the log of q0, where q0 is the initial charge. And that would be the particular solution, but again, in implicit form. You might have to carry on from that and get the explicit form in the form q equals something. So let's carry on and try and do that. So if I carry on and solve this, what I would do is I would take the log q0 over the other side. So log q minus the log of q0 equals minus t over rc. Using the laws of logarithms, log of a over b equals the log of a minus the log of b. And of course that log could be an ordinary log or a natural logarithm, which it was in this case. So I could rewrite log q minus log q0 as a log of q over q0. Equals minus t over rc. Getting rid of the natural log by finding the exponential function of both sides, we get q over q0 equals e to the minus t over rc. Bringing the q0 up to the other side, we get that q equals q0 e to the minus t over rc, which is the more generally accepted way to write the solution to that differential equation, and might well be an equation, or a formula rather, that you're familiar with. part B of this particular question, you're asked to use this equation that you've come up with, this solution to the differential equation, to find some values. And in an exam question, you might well be asked to use this function to find some values, but also show where the function came from, which is what we've just done in that previous question. You're given some values. You're given the value of the resistance is 250,000 ohms, or 250 times 10 to the 3, and that the capacitor is 8.5 times 10 to the minus 6 farads, or 8.5 microfarads. So it's common, given those values, to find out what R times C is, which turns out to be 2.125. And you might remember that RC is the time constant, tau. So 1 over RC, which is really what we're after, is 0.471. So instead of writing in this formula minus T over RC, we can write minus 0.471 times T. So this simplifies this function for this particular circuit to give us this. So now, after 0.32 seconds, given that Q equals 8 coulombs, after 0.32 seconds, we could find Q0. And I'm sure you can do that. Once you've found the value of Q0, the next thing to do is to find Q after 1 second. So use the value of Q0 that you just calculated, and then let T equal 1 second and find what the charge is after 1 second. Have a go at those and check your answers on the sheet, that you agree with the answers on the sheet.